Hello students, let us start the second chapter, that is software processes. So these are the topics that are going to be covered, uh, like software process models, process activities, coping with change, then the rational unified process. So these are the various topics that are going to be covered from this chapter. First, let us see the definition of a software process. What actually a software process is? A software process is a set of related activities that leads to the production of software product. That is, if we want to build any software, then these are the activities that we will follow so that we will be getting a software product at the end. There are many software processes. There are various kind of processes, but all involve like specification, design and implementation, validation, evolution. Whatever might be the process that you are going to go with, you will be following a specification stage. Then we have design and implementation, then validation, at the last evolution. So these are the basic things that we will be having in every process. First, let us have a look at specification. Software specification is the functionality of the software and constraints on its operation must be defined. Here we are going to define what actually the software does and what are the constraints under which the software is going to work. So that is your software specification. Then we have design and implementation part, wherein we will be looking at the software to meet the specification must be produced. Whatever the specification we have, by looking at that we will go for designing the things, and once design of the software is built, we'll go for implementing that design. Then we have validation phase. In validation phase, what we do is checking that it does what the customer wants. Whatever is asked by the customer, that product only we have to give it to the customer, or else he will not accept that product. And the last phase is the evolution phase. In the evolution phase, what we have is changing the system in response to changing customer needs. That is, during the evolution phase, what we do is we will change the program. Okay, why we are going to change the program is either because there is some bug present in the system that we have developed, or else the customer requires some additional things to be added to the system. So because of this, we go with evolution phase. The software process model is an abstract representation of a process. Whatever the process we are going to have, here this software process model, it's an abstract representation of a process. It tells us regarding the important things that are needed for having a product. It presents a description of a process from some particular perspective only. Then we will see at software process descriptions. When we describe and discuss process, we usually talk about the activities in these processes, such as specifying the data model, designing a user interface, etc., and the ordering of these activities. Process descriptions may also include, apart from the general things, it also includes three other things like the products, which are the outcome of a process activity. That is, whenever we have uh, gone with a particular stage, we'll be having a byproduct. For example, outcome of the activity of architectural design may be a model of the software architecture. Then we have rules, which reflect the responsibilities of people involved in the process. That is, like who all are involved in development of a application. Their role is designed and defined over here. For example, project manager, configuration manager, programmer, etc. So these are the different roles in the development of a software. Then we have pre and post conditions, which are statements that are true before and after the process activity has been enacted or a product produced. For example, before architectural design begins, a precondition may be that all requirements have been approved by the customer. So that is a precondition that we'll be looking at when we have a architectural design. That is, before actually starting architectural design, we are seeing a precondition. What's that precondition? That is, precondition may be that all requirements have been approved by the customer. During the life cycle of a software development, first we'll have a requirement collection. Okay, so here we are checking that whether all the requirements have been approved by the customer or not. After this activity is finished, a post condition might be that UML models describing the architectures have been reviewed. So this is regarding the precondition and the post condition. Now we will see the difference between plant driven and agile process. Plant driven processes are processes where all of the process activities are planned in advance and progress is measured against this plan. In plant driven model, what we have is everything is planned. Like what should be the duration for the particular activity, who will be handling the particular work, and what cost is required, what is the time frame required, when it is going to be delivered. Everything is fixed over here. That is, before starting any development of any project, we'll be having full plan. Then only we will be proceeding with the things. Then we have agile process wherein planning is incremental. Here also in agile process also we will be having a planning, but the thing is planning is incremental. But in plan driven model, what we will have is in the initial only we are going to have the plan for each and every activity right from the requirement collection up to the evaluation process there. But the thing is planning is incremental. That is, we will have a smaller planning for either 1 week or 10 days or the fortnight and all. We'll not have a plan for 1 year 2 years and all. And it is easier to change the process to reflect changing customer requirements. When we follow a incremental model, the customer will come up with requirements that can be easily handled. In practice, now we will see in practice what is going to happen. Whether we will be following a plan driven model or agile process, it depends on the scenario. That is, in practice, most practical processes include elements of both plan driven and agile approaches. If you're building a very large project, therein there what we will do is some requirements which have been collected fully, there we will apply a plan driven method, and where there is a frequent change of requirements from the customer, there we will follow agile approach. So when we are building an application, a part of the plan will be a plan driven model, and the little bit portion will be of agile approach. There are no right or wrong software processes. If you're dealing with any software development, there is no right or wrong. It depends on the scenario, and according to the scenario, we will be choosing whether we have to go with a plan driven model or whether we have to go with agile, or it's a combination of both the methods. Here we have three kind of software process models. First one is a waterfall model, then second one is incremental development model, third one is reuse oriented software engineering. The waterfall model, it's a plan driven model. Just we have gone through a plan driven model. What do you mean by plan driven model, and what do you mean by agile over there, right? This waterfall model, whatever we are considering over here, it is a purely a plan driven model wherein separate and distinct phases of specification and development are present. Second one is incremental development model. Here, specification, development, validation, everything is interleaved. There is no separation gap between the specification, development, and the validation things. And it may be a plan driven or agile. It can be anything like incremental development model. Like some part might be developed by considering a plan driven model, and something might be from your agile. Then we have reuse oriented software engineering. The system is assembled from existing components, maybe plan driven or agile again. But the thing is, waterfall model should be a plan driven model only. We cannot go for agile model over there. In practice, most large systems are developed using a process that incorporates elements from all of these models. Whenever we are building a bigger projects, some part is developed from waterfall model, some for building some part we'll be making use of incremental development, and whenever we feel that some part is already built by someone and it can be reused in our project, then we will be making use of reuse oriented software engineering model. Let us go in depth regarding waterfall model. Why it is a waterfall model is just if you look at this model, we can come to uh, a conclusion that it depicts a waterfall model. That is, waterfall, when a waterfall's on a higher place, then what happens is it goes to the bottom place, then from there only it can be going to the vapor state. It's similar to this. Here what we have is, we have various stages, uh, like requirement definition, then system and software design, implementation and unit testing, then integration and system testing, then operation and maintenance. So these are the various stages. Here what happens is, until and unless a requirement definition stage is fully completed, we cannot go to the second stage, that is system and software design. And once you are done with system and software design, you cannot come back and change the requirements over there. So this is one of the disadvantage of having a waterfall model. In waterfall model, if you come to know that there is some problem in the previous stage, you cannot go directly back to the previous stage and rectify it. What you have to do is, you have to go to the last stage, that is operation and maintenance stage. From there you have to return back where actually there is a problem over there. So that is, whatever the model we are going to have, it will be having its own advantages and disadvantages. So these are the separate identified phases in the waterfall model. As we have seen in the previous diagram, what it has is, it is having requirements analysis and definition, system and software design phase. Then we have implementation and unit testing, integration and system testing, operation and maintenance. So these are the various stages. So in requirements analysis and definition, what we have is, the system services, constraints and goals are established by consultation with system users. They are then defined in detail and serve as a system specification. Here what we do is, this is the first phase of development of any software, wherein we are going to collect the requirements from the users, and once it is done, it will be documented. Then by looking at this document, next phase starts. So system and design, software design phase starts only after the completion of the requirements analysis and definition. Now let us see regarding system and software design, what's going to happen in this phase. The system design process allocates the requirements to either hardware or software systems by establishing an overall system architecture. Here we will be having the overall architecture of the hardware and the software. Software design involves identifying and describing the fundamental software system abstractions and their relationship. If you want to build a software, it can be divided into multiple pieces. Right now, here you have to identify how one part is related to other, how it is having a connection with other things. So that is what we are going to have in a system and software design phase. Once this is done, we'll go for implementing the code. Okay, that is, during this stage, the software design is realized as a set of programs or program units. Here we will be writing the code for a application. Once that is done, we go for unit testing, wherein whatever the units that we have prepared, that is going to be tested separately. Then we go for integration and system testing. Once the unit testing is done, what we will do is, the individual program units or programs are integrated and tested as a complete system to ensure that the software requirements have been met. What we will do is, once unit testing is done, we go for integrating all the components. Then we will see that when we have added all the components, whether the system is working as a whole or not. So after testing, the software system is delivered to the customer. Once we come to a conclusion that whatever the system that was requested by the customer, it is bug free, there is no problem in that, then we can give it to the customer. Then the last thing is operation and maintenance phase. Normally, this is the longest life cycle phase. Why it is the longest life cycle phase is because the customer's demands are not going to be stopped, right? He'll be coming up with new requirement daily wise over there. The system is installed and put into practical use. Maintenance involves correcting errors which were not discovered discovered in earlier stages of the life cycle. Okay, there might be a scenario wherein we might have not correctly analyzed the things and all, because of which there were a lot of problems in the coding that we have written. Then what happens is these codes are going to be masked somewhere, but when we go for testing rigorously before giving it to the customer, then we will come to know. Or sometimes after we have given it to the customer will be finding a bug in the product that we have developed. Then he will be coming for corrections in that, and then we will be developing the things, that is we go for operation and maintenance phase, wherein the bugs are going to be removed, and then the correct software is given to the user. The main drawback of the waterfall model is the difficulty of accommodating change after the process is underway. One of the problem of this waterfall model is, if there is any problem in the previous stage, then we cannot go back and rectify it until unless we go for the maintenance and the operations phase. That is, in principle, a phase has to be completed before moving on to the next phase. That is again a drawback of this waterfall model. Apart from that, there are a lot of problems. One is inflexible partitioning of the project into distinct stages makes it difficult to respond to changing customer requirements. Here, one problem is we cannot divide the project into multiple stages. That is one problem. And another thing is, if there is any problem in the previous stage, then it cannot be repaired in the next stage. What we have to do is we have to follow all the steps. We have to go to the last phase, that is operation and maintenance. Then we have to rectify the things. Therefore, this model is only appropriate when the requirements are well understood and changes will be fairly limited during the design process. Few business systems have stable requirements. Only few of the business that we have, it's having a stable requirements. In that, we can go with the waterfall model. The waterfall model is mostly used for larger system, wherein we go with large systems engineering projects where a system is developed at several sites. Let us consider we are building a very big project wherein the people who are working on this project are in different countries or in the different continents and all. Then we go with the waterfall model. Uh, Waterfall model. Okay, the thing is, because everything is decided in advance, then the work is divided into various teams and it is given to the respective teams wherein they will be doing the work allotted to them. So only in such conditions the waterfall model is going to have its existence. Then second one is a incremental development model. So this is another one model. What we will have is, in this model we will have an outline description. By having this outline description, we will have a set of concurrent activities like specification, development, validation. Here all these three things are interleaved. That is, there is no separation in the various stages. That is, when you are building a project, whatever the things you have understood, you will be going for the development, and if development is done, then you go for validation. But there might be some part of a product which is not understood properly, then you'll be consulting the various customers, they'll be giving the feedbacks, and like this you'll be developing the things, that is specification, development and validation. So these are the concurrent activities. Okay, that goes hand in hand. Okay, then what we'll have is, we'll have initial versions, like whatever the things you have understood properly, for that you will be writing the code, go for validation, and you will give it to the customer as an initial version, which is not having all the requirements given by the customer. Only whatever you have understood, you will be deploying it and you will be giving it to the users, and users are going to work with that. Then we have a intermediate version. Okay, then what we will do is, we'll go on adding the functionalities to the product that was released in the initial version, and that is a intermediate versions. You can see there are a lot of intermediate versions. Okay, it's not that we'll be having only one intermediate version, then we'll be having a final version. No, we'll be having a lot of intermediate versions. Then once everything is done, then we'll be releasing the final version. So this is how the incremental development model works. We will see what are the benefits of having an incremental model. The first benefit is the cost of accommodating changing custom requirement is reduced. That is, whenever we have a customer, he'll be coming up with a lot of requests. So if you go with the waterfall model, there will be a lot of documentation work that has to be analyzed and that has to be rewritten once again. But if you go with this incremental model, the less documentation is required. Then second one is it is easier to get customer feedback on the development work that has been done. You have seen in the previous slide that is once a part of a functionality is developed, it will be given as the initial version to the customer. Then customer will be using that and they will be coming up with their suggestion to the product that will be developed later. So what we can say is it is easier to get customer feedback on the development work that has been done. But if you compare it with the waterfall model, in waterfall model what happens is the customer will be getting a product at the last. That is, once all the requirements have been collected and they have been developed and given to the customer, then only they can use the product and they can comment on it. But in incremental model what happens is, as we know that initial version, intermediate versions and all, they are given to the customer. They can look at that product and they can give their own suggestion. And the third important benefit of having an incremental model is more rapid delivery and development deployment of useful software to the customer is possible. Customers are able to use and gain value from the software earlier than is possible with a waterfall process. As I already said, in the waterfall model we will be giving the product to the customer when each and everything is done. But in incremental model what happens is once a part of a functionality is developed, it will be given to the user and user can comment on that. Now we will see what are the problems with incremental development model. First thing is the process is not visible. That is, our managers need regular deliverables to measure progress. If systems are developed quickly, it is not cost effective to produce documents that reflect every version of the software system. The first drawback is managers cannot tell whether they have done with the specification phase or they have done with the deployment or they have done with the validation phase. Because if you follow a waterfall model, then we know that once you are done with the requirement phase, the next phase is your a design phase, right? Once a design is done, then you go for implementation. Once implementation is done, you go for operations and research over there, right? So we can say that we are in so and so stage. But if you consider an incremental model, there is no specific stage. So the managers feel a little bit difficult in handling the progress. The next thing is system structures tends to degrade as new increments are added. Once a software is being produced and the customer will come up with a requirement, we'll be having an initial version of the software. Okay, whatever the version we have over here, that will lose its structure because of the changing requirements from the customer. Unless time and money is spent on refactoring, that is, here we have to go with the process known as refactoring to improve the software over there, the structure of the software. Then regular change tends to corrupt its structure. Incorporating further software changes becomes increasingly difficult and costly. That is, what happens is as the customer comes up with lot of modification, then what happens is most of the things have to be rewritten. All the things is going to happen. So the software cost is going to be increased. Then we have reuse oriented software engineering. It is based on the concept of like nowadays no one is building everything from the scratch. If you want to develop anything or any software product, what you do is first you will look in the market whether you find a particular component which is readily available. If it is readily available, then what you do is either you buy it if it is sold as a commercial product, or else if it is a free version, then you will be using it. Then you can modify according to your need. So this is regarding this reuse oriented software engineering. Here the various stages are, here we have lot of stages for the reuse oriented software engineering. That is, you can see in the next slide: requirement specification, component analysis, requirement modification, system design with reuse, development and integration, and system validation. So these are the various stages of the reuse oriented software engineering. But the thing is, requirement specification is common to all the things, and validation is also common to all the models. But in that, we have component analysis, which is a specific stage of the reuse oriented engineering. Then we have requirement modification, system design with reuse, and development and integration. So these are the specific stages of this reuse oriented software engineering. We will glance it over here. What is component analysis? It is nothing but, given the requirement specification, a search is made for components to implement that specification. Usually there is no exact match, and the component that may be used only provides some of the functionality required. First we will look at the component, whether a component that is required for a project, whether it is readily available. If it is readily available, then we will be buying it and we will be incorporating in our project. Then second one is requirements modification. During this stage, the requirements are analyzed using information about the components that have been discovered. They are then modified to reflect the available components. Then what we do is, where modifications are impossible, the component analysis activity may be re-entered to search for alternative solutions. So this is going to happen during the requirements modification phase. Then we have system design with reuse. In this phase, what we do is, during this phase, the framework of the system is designed, or an existing framework is reused. The designers take into account the components that are reused and organize the framework to cater for this. Then some new software may have to be designed if reusable components are not available. If reusable components are not available, then what we have to do is, we have to develop by ourselves. And the last thing is development and integration. Software that cannot be externally procured is developed, and the components and core systems are integrated to create the new system. Then what we do is, system integration in this model may be part of development process rather than a separate activity. Then once this is done, we'll go for the system validation, which is similar to all the models. Here we have types of software components. We have three different kind of software components. First one is web based, that is web services that are developed according to service standards and which are available for remote invocation. So this is one kind of component that we are looking whether it is readily available. Then we'll be looking for some collection of objects that are developed as a package to be integrated with a component framework such as .NET or J2EE. And the third kind of component that we will be using in our projects is standalone software systems, that is we call them as COTS, commercial off-the-shelf systems that are configured for use in a particular environment. So these are the different kind of software that we are going to software components that we are going to use. Okay, thank you.